All right, so today we're going to work on solving simultaneous equations using graphing. This is a little bit more challenging as we do have to put it first into what we call slope form. Remember slope, and I'll put this here, slope form is y is equal to mx plus b. So often it requires a little bit of arithmetic, and we got to move the pieces around so that y is by itself, okay? So let's go ahead and convert these into slope form. For the first one, x plus y equals 9. So that's easy. I can just subtract x from both sides. So I'm subtracting x, and I end up with this form. For the second one, I have a negative y, so this might take a couple of steps. Let's see here. It's fine. I'll just rewrite it here down at the bottom for us. So we have 2x minus y is equal to 3. We're going to subtract our 2x. We get a negative y. Because there's a 3 and a negative 2x, remember, that's an unknown value. We cannot combine those two. So we get a negative 2x plus 3. But again, that doesn't give me a y by itself, so I have to multiply everything by a negative 1 or divide it by a negative 1. Okay, either is fine. Negative times negative gives us a positive. So it changes all the signs. All right. So I'm given two equations. And it's important to understand the slope form because, remember, slope tells us rise over run. Or we can think of it as the change in y over the change in x. Meaning, does it go up and down? How much? And to the right or left? How much? B is our y-intercept. And that's important to recognize. That's where it crosses the y-axis. For our y-intercepts, we know it's going to be 9, and over here, a negative 3. Okay. Our slope here, there isn't one that is seen in the first one. Our slope is in front of our x, right? Our slope is the m. Okay. There is a 1 here, remember? We talked about this in the previous videos, where there's always a 1 in front of our variables. We don't write it because 1 times anything is itself. Okay? And over here we have a positive 2 slope. Okay? And slope is written as change in y over the change in x. So that means for these slopes, this will be written or seen as negative 1 over 1. And this one will be seen as draw an arrow, 2 over 1, because 2 divided by 1. All right. Now that we got that sorted out, we're going to go ahead and draw our graphs. All right. I'm going to count by, well, let's just count by ones. That's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. 1, 2, 3, 4, 5. There's negative 5. All right. So, again, let's start with the first one. I'm going to do this one in in green. So we're going to find our positive 9, put our dot there. And our slope is negative 1 and over 1. Negative 1 and over 1. Now, we honestly don't need to do this for all of them because normally we have a ruler and it's in place and we can just go through 1 and 1, 1 and 1. I'm kind of losing my spot here. It helps when we have a line, huh? All right. So, notice all of them coming together, it forms a line. There we go. So that is our first formula, and that is our y is equal to a negative x plus 9. I will do the next one in red. Our our y-intercept is negative 3, so 1, 2, 3, put a dot. And our slope is 2 over 1. So we're going to go 1, 2 up and over 1. 1, 2 up over 1, 1, 2 up over 1, 1, 2 up, and over 1, and continue. 2 up and over 1. And it should form another line. All right, that one's a little off. And we want to figure out, where does it cross? It crosses at this point right here in the middle. So 1, 2, 3, 4 should be. Let's see here. 1, 2, 3, 4. Yeah, it should have been 4 there. It's a little bit off. Apologies. And it looks like points 1, 2, 3, 4, 5. 5 up. 1, 2, 3, 4, 5. So it should be right about there. So it's 4, 5 is our solution. If you have a graphing calculator, it can be really helpful for us to see the graph. But notice it does go up, and it should cross at that point. To check, you can always substitute your x's back in to see if it works, and your y's back in to see if it works. Okay, we can go over another video on how to do that later on as well. All right, good luck.